Exercise, exercises 4 through 6 on this assignment give us an idea of how to use the remainder theorem to answer a couple of types of questions. Like, think about question 4. It says, consider the polynomial p of x, which equals x to the third plus kx squared plus x plus 6. And we want to find the value of k so that x plus 1 is a factor of p. Well, let's reason out a couple of things. If x plus 1 is a factor of this polynomial, then x equal to negative 1 would cause that factor to equal 0. And we know that if negative 1 makes this factor equal to 0, it's going to make the entire polynomial equal to 0. So another way of thinking about this question is, if I put negative 1 into this function, what value of k is going to make it equal to 0? So I'll get you started here. If I put negative 1 into this function p, it looks like this. Always mind those negative signs. Okay. And my question is, I want to force this to equal 0. So now I can solve this equation for k. So I'll leave that as an exercise. If you can evaluate and simplify this expression using, of course, the order of operations, and then determine what value of k actually makes this statement true. And then you could rewrite the polynomial, and instead of the k, you would just insert the value that you determined there. The next question asks you to find the other two factors of p for the value of k that you found in part A. So once you've described your polynomial completely and you know what k is, you should be able to divide out that factor x plus 1 and factor this whole thing. You guys should be pretty comfortable factoring third-degree polynomials, especially when you already know a factor. So try to rewrite p in its factored form. In questions 5 and 6, they're basically just variations on this same question. Consider this different polynomial p of x, and it's asking, is 1 a 0 of this polynomial? You know what that means. If you put 1 into this function for x, is it going to give you 0, yes or no? So you have to do a little work in order to answer that question. All right? And again, is x plus 3 one of the factors? Well, to answer that, go back to this question. Think of how we approached this question in order to answer that. And finally, here you have a graph, and it's asking you to find the zeros and then write the equation. And I hope that you can use the zeros of this graph in order to write the equation of p in factored form. And remember, when you write an equation, it should have an equal sign. Okay? So try to get through exercises 4 through 6.